This video will present solutions to the 2018 VCE Mathematical Methods Written Examination 2. Section B, Question 2. Question 2. This question involves modelling the amount of drug in the bloodstream using this function. I'm going to define this function in my class pad as f of x, as this will allow me to use a user-defined function later in the question. Part A. My first computation is to find the time in hours that it takes for the drug to reach its maximum amount, and I can do this using the fmax command applied to my function f of x. Looking for the time taken to reach this maximum value, we need to simplify our answer so it is in the form required. Hence our answer is that the function is at a maximum when t equals 10 on 7 log base e of 9 over 2. Part B requires the average rate of change of the function across the region from 2 to 6. This can be computed using a user-defined function if you have one, or it can be computed using the relationship b of 6 minus b of 2 all on 4. On our class pad, this calculation looks like this. We can convert this to a decimal so we can provide our answer to one decimal place. The same calculation can be done using a user-defined function if, like this class pad, yours has one previously defined. User-defined functions can be found in the catalogue. My function requires only the inputs of 2 and 6 as it refers to the function f of x as previously defined. Returning the same value. Part C. The average amount of the drug in the bloodstream during the first 6 hours can be calculated as 1/6 multiplied by the integral from 0 to 6 of the function. I'll perform this calculation on my class pad. To the nearest milligram, this answer is 256. Part D. In this part, a second tablet is consumed, and we are asked to think about the total amount of the drug in the bloodstream across the first 12 hours. The total amount will be equal to tablet 1, b of t, plus tablet 2, which is b of t take 6, a translation of the original function. This can be graphed using our class pad. Setting our view window to the one provided is going to be required. This graph looks useful, but it would be even more useful if I could see f of x at the same time. Now we need to transpose our graph onto the axes provided. It is useful to trace here to locate our answer correctly. We can see at 6 the function is at 190. At 7 it is as high as 422. At 8, it is close to a maximum value, it would appear, of 454, and from there we can see it decreasing. At 9, it's down to 416. At 12, giving us a value of 250, helping us to get our shape approximately correct. D part 2. Now we need to find the maximum value of the drug in the bloodstream across the first 12 hours, given that 2 tablets have now been taken. As this calculation is required to correct 2 decimal places, we can do this calculation on our graph. This gives a maximum value of 455.82 milligrams at the time when t equals 7.78 hours.